For homework, I wrote a contract where the implementation at the moment is just close, and I would like you to implement that properly. So this is, I think, much easier than this multi-pay contract that we looked at. But nevertheless, for people without programming experience or much programming experience, it might be a bit hard. Of course, you don't have to do this in Haskell. You can also do it in JavaScript if you like. But what you can also do if you find this too difficult is go through the contracts from last lecture. I mean, these simple payments or choice if and so on, and try whether you can do something similar to what we did here with the double pay. So just try to simplify those programs. Of course, they were simple already, but maybe you find a way to write them in a nicer form in Haskell or in JavaScript. Okay, so the idea here is it takes a couple of parameters. So the rough idea is that you have a bank and a client, and the bank first makes a large deposit, and then the client makes a couple of small deposits. And if the client makes all his deposits, all the expected ones, then he will get all the money in the end. So the deposit of the bank and his own deposits back. If, however, at some point he stops making deposits, then the bank gets its own money back, but also all the deposits that the client has made up to that point. So the parameters are the first and the second are the party for the bank and the client, then the number of rounds. So that's actually what makes it interesting. So the number of deposits that the client is supposed to make, because that means that the structure of the Malo contract will be different. So if you have a different number of deposits here of rounds, then the contract will also be different in its structure. So it's not just values like times or values that change, it's the contract itself that changes because then more deposits by the client are expected. Then this is the amount that the client has to pay in with each deposit. And the rule is that the bank has to pay the total. So if it's 5 rounds and this here is 10 ADA, then the bank would have to pay 5 times 10 equals 50 ADA. The first timeout is the timeout until when the bank has to make his deposit, and the second timeout is the timeout until when the client has to make all his deposits. So I can demonstrate that for this special case here. So we have party bank is called bank, the party client is called client. There will be 5 payments expected by the client, each over 50 ADA, and the time parameters are just parameterized. So it's called bank deadline and deposits deadline. I have that here in the playground. So I have to specify these two deposits. Of course, realistically, they would be much farther apart than just 5 minutes. So let's try it. So the first action is the bank must deposit 250 ADA. So and if the bank does that, so now it's up to the client and he can make deposits 5 times. 1, 2, 3, 4, 5. And if he has done all the 5 deposits, then the bank pays the original 250 to the client. If, however, the client stops, let's say after 3 deposits, the client stops and doesn't make a further deposit, then all the money that he already paid, in this case 150 ADA, go to the bank. Yes, and so the idea is to make that variable. So here it was 5 rounds, 5 deposits, but I can change that and generate a Malo contract for like 10 deposits or 3. So I hope you enjoy this exercise. I hope it's not too difficult. And as I said, if you want, you can try to look at our earlier contracts and do them in JavaScript or Haskell and try to simplify them somewhat. So to summarize, in this lecture, we looked at writing Malo contracts in Haskell or in JavaScript. So the idea is a quite powerful one. It's like the idea of metaprogramming. Metaprogramming is programs writing programs. So you can consider Malo contract as a very simple program in a very simple programming language. And you can use Haskell or JavaScript or also other programming languages to generate such Marlowe contracts. So you have program writing programs or contract writing programs. And doing that, it's possible to have quite a short, simple Haskell or JavaScript program that generates quite complex Marlowe contracts. So if you know a little bit of programming, then using this technique, you can write really complicated, complex, long Marlowe contracts with a few lines of code.